So hello everyone. Let me reintroduce myself. My name is Cyril Sadowski. I am a lead application developer at Deutsche Telekom. And apparently today I am here to talk to you about artificial intelligence. So intelligence itself is a really hard problem. The universe itself has been working on artificial intelligence for 14 billions of years. And for example, almost always when I leave my apartment, I forget my car keys. So apparently it wasn't quite able to solve the intelligence problem. Anyway, we have smart people. So Charles Babbage and Ada Lovelace had the first attempts at automated intelligence. This was done in the 19th century, if you can imagine that, in the 1830s. So Charles Babbage came up with his analytical engine, which was basically a mechanical computer. And then Ada Lovelace realized that the outputs from this mechanical computer that were numbers could represent different things, different symbols, for example, words, or different outputs. So it is thought that Ada Lovelace in the 19th century was actually the first software developer that ever existed in the world. Now, these were very smart people, and they were way ahead of their time. So for the next about 100 years, nothing happened. But then came this guy, Alan Turing. He came up with the first abstract framework to think about intelligence. We call it today a Turing machine. Of course, he didn't call it a Turing machine when he invented it. But what is a Turing machine? Turing machine is basically a computer. Your smart device that you have in your pockets right now, your iPads, your laptops, everything is Turing machine. If we want to continue to talk about intelligence, we should try to define intelligence. So we have to talk about System 1 and System 2 thinking. System 1 thinking is your intuition, is your insights. It's your fundamental understanding about concepts. Your intuition is really hard to define. It's you standing in front of a refrigerator in the middle of the night. You don't know why you got there, how you got there, but you will take the snack. Anyway, there you go. This is System 1 thinking. System 2 thinking, it is deliberate, it's algorithmic, it's definable, it's transferable. This is you learning how to drive a car from a manual. And this is very important, and I will stay sometime on this slide. These two systems, System 1, the intuition, and System 2, the algorithmic thinking, form a feedback loop. Imagine you are a child. You see a flame or a fire for the first time. You know, it's interesting. It moves, it flickers, it's bright. So what is your natural response if you see something interesting? Well, you will touch it. But then comes the feedback loop. Suddenly, through pain, the child realizes that it has to form a new algorithm, meaning if I see a flame, then I do not touch the flame. So after several attempts and several tries, the algorithmic thinking, if I see fire, don't touch, then gets ingested basically into your brain, into the child's brain. Your neurons form an intuition. And now as an adult, if I see a fire, well, I probably won't touch it. So this feedback loop basically gives us humans and some animals the ability to create world models, effective world models from which we can basically extract value and do interesting stuff, like driving a car automatically, do plumbing, or maybe give talks about artificial intelligence like I'm doing right now. Hopefully it's useful. What does it mean from the point of intelligence automation? So we try to define what intelligence is It's basically a feedback loop between intuition and deliberate algorithmic thinking. Now we have to talk about how to transfer this knowledge into machines. So system 2 thinking, the algorithmic thinking, is rather simple. This has been already solved by Alan Turing about 100 years ago. And system 2 thinking is a Turing machine, meaning it's algorithmic, it's computational, we think like computers. So maybe you didn't know about this, but we as human beings are also defined as Turing complete. And this is the missing piece of intelligence. System 1 thinking. What can we do from the point of machines to give them intuition? And I would argue that generative AI is the missing piece, is the system 1 thinking, the intuitive thinking. So I want to prove that to you. Let's do an experiment. Problem statement. Building a home automation system. And I deliberately chose building home automation system because I have no idea how to build home automation systems. So what do? I go to my local ChatGPT, or maybe you can use Claude from Anthropic or Gemini from Google. So I'll ask it, help me define a ubiquitous language for a simple home automation system. Now, please concentrate on the term ubiquitous language. This is very important. For your particular domain, we have to be able to define general language that is understandable by the whole company. So the AI then gives us an output. We can define a device, which is, for example, a light, a state of the device, which can be, for example, on or off, an action that can be done upon that device, so we can turn it on and off. We can define a trigger and rule, etc. And this is very important because this might seem very, like, what can we do with it? But if you have internal Wikipedia or documentation in your company, and you can extract ubiquitous language for your domain, you can then, for example, copy-paste into your Wikipedia or internal documentation these definitions, and whoever opens your internal documentation, it can be engineering staff, it can be business people, managers, we can start to define what do we in our company mean by device. Because for someone, device can be an iPad, but for us within our domain, it's, for example, a light. Now let's move a step further. So I ask, for example, ChatGPT, great. You say I'm very encouraging. So great. Now help me define symbols or a simple syntax for these concepts that could be translated into a programming language. Now we can see here that this output for device, state, action, trigger, and rule is very similar to this more human-like readable way of expressing what particular terms mean. But now we have something that is called symbols. This is kind of an abstract programming language. We can do stuff with that. Can you give me a simple example of how these symbols might be used in a home automation rule? For sure. So we have two variables or two devices. We have a light in the living room, and then we have a sensor on the front door. If we sense, if the sensor on the front door senses that the door had been opened, then the light in the living room will be turned on. So we can already see we have this abstract language with which we can define logic that everyone can understand, even machines. So this is the missing piece of intelligence from the point of view of machines. System 1 thinking is generative AI. Now this is very important because basically what companies do today, so imagine you are building a home automation system and you would have to hire a domain expert to give you the intuition about building home automation systems. Now you have the intuition of the whole humanity at your fingertips, because things like ChatGPT, Claude, or Gemini have been trained on the whole internet. So instead of having to talk to someone with intuition about particular domain, I can use generative AI to extract useful and actionable knowledge. System 1 plus System 2, so remember, the intuition plus Turing machines from the point of view of machines equals Neuro Symbolic AI. This is an important concept that we will be hearing about a lot in upcoming months and years. This is the combination of intuition, the generative AI, and Turing machines, the computers that we already have today. This is the feedback loop. This is the capability of machines, of computers, to be able to learn interesting and, most importantly, useful and valuable stuff. So symbolic representation of extracted knowledge. On the left-hand side, you can see a screenshot of a product that we are building in Deutsche Telekom. It's a Neuro Symbolic product. And this knowledge graph actually represents this code right here. So meaning you can see that you can, if you have specialized symbols, you can represent the knowledge in any way you like this, or in a programming language, or in knowledge graphs like this. So knowledge graphs are they are useful because generative AI like ChatGPT, etc., can understand knowledge graphs very well. So the whole industrial revolution was about automation, extracting more value for less input. Neurosymbolic AI is actually, from my point of view, next step of this automation, continuing the industrial revolution. Remember, less input, more value. We can have streamlined communication, common language for humans and machines. We can have more precision in execution, decreased ambiguity in communication, and reliability enhancements. So, Neurosymbolic AI, it is a means for building robust and reliable systems faster, basically decreasing ambiguity. We are just starting to build these products right now. Maybe you have heard about Google DeepMind's AlphaGo, AlphaFold, AlphaGeometry, AlphaProof, extremely successful products within the AI realm, and all of them are built on Neuro-Symbolic approach. So right now, I would like to end with this post from Claudia Nemat. Claudia Nemat is an executive board member of Deutsche Telekom. Let me read it for you. The AI hype is ending, according to the media, and that would be good news. Why is that? Finally, we can focus on creating value with AI, instead of worrying about cycles, inflated expectations, or disillusionment. And I fully agree with this statement. Right now, it's time for real, honest, thorough integration engineering work within the AI realm to build neurosymbolic products and bring real value to the companies within the AI realm and bring companies to productivity with AI. This is very important from my point of view. So, if you want to know more about our approach towards neurosymbolic AI, if you want to know more how we think within Deutsche Telekom about implementing neurosymbolic AI, please scan this QR code and you will know more about the theory machine.